A requirement that is more popular nowadays in data centers is the need for overhead cooling units, or the desire to put in overhead cooling units. In this session of CoolSim, I'll be showing you how to put in overhead cooling units. As you can see here, I have created a room. If we double click on one of the walls, we'll see that it is a non-raised floor data center with a ceiling plenum return. We have dimensions here. The room is 40 by 40, the height of the room is 10 feet, and the ceiling plenum is 10 feet deep. Now, the ceiling plenum can be thought of as the roof of the data center, or it can be a ceiling plenum like you would have in a normal raised floor data center with a false ceiling. Either one will work. We're assuming an adiabatic heat transfer through the surface of the roof anyway, so either condition can be modeled this way. So the first thing I need to do is get a cooling unit in the room of the size I want. Now, when you drag in a cooling unit into a non-raised floor data center in CoolSim, it comes in as a in-row unit because that's normal. So we just default it to be in-row. We're going to leave it that way. I may rotate it just 90 degrees so that it's pointing in a direction I want. Then I'm going to change its shape. I'm going to let's make it a 2 foot by 2 foot design. I don't know exactly what they are. Maybe they're 3 feet. Let's go for 3 feet. So let's make it 3 feet tall, and we'll make it 3 feet in the z direction, which is really its depth. And in terms of the x direction, it doesn't really matter how deep you make this thing, because we're just modeling it anyway. It's not as if it has to be the depth of a real unit, but we'll make it 2 feet. Now you'll notice that the inlets and outlets there aren't quite sized to the size of the unit, because we can't assume when we make these adjustments in geometry where you want your inlets and outlets. But one of the nice things here we have in CoolSim is an automatic feature. So we'll slide down under the Geometry tab and we'll say Modify Supply. And if we auto-distribute, it will just make it the size of the block. You can do this any way you want. You can have multiple supplies here, supply outlets. You can offset them any way you want. But in this case, I'm going to do just the one. So I auto-distribute and apply. And I do the same thing on the return. I auto-distribute and then apply. And what that does is it makes the inlet and outlet the same exact size as the block itself. Okay, so there's my cooling unit. I can rename it if I want. I can set the parameters of it, of course, to be whatever I need it to be. Use a fan curve on it if I want. Use different kinds of boundary conditions, which I cover in another section. I can also put a performance curve in here if I want. I could use it as a fan only if I want, to just create a fan wall or to create a fan movement of air, whatever I like. Okay? But one of the things I do need to do is get it up in the ceiling, of course, so I need to change its geometry position. Right now it's sitting on the floor. I know my ceiling is 10 feet tall, of course, before I go to the outside. So I'm going to start it at 10, and that'll move it up in the air. And so now if I look at it from the top position, you'll see that I have a overhead cooling unit sitting in the plenum, the ceiling plenum. Now, to do duct work here is really quite simple as well. All I have to do is drag in a new piece of duct from my ducting tool. Now, it sits in the room at first, okay, but you can simply edit that and put it in the ceiling. So here I just want to move it up. I'm going to start it as well. It's starting at 8. I'm going to start it at 10. I'm going to move it up into the ceiling along with the cooling unit itself. All right, now here's my Duct Designer tool. This is a very handy way to model and to use the Duct Designer. You can do everything from this panel. You can add diffusers. You see here I can add diffusers. I can add ducts. So this is the full panel. There's really two panels with Duct Designer. One of them is the full panel itself. The other one is a sub-panel for putting in just ducts and diffusers. Let's start with the length of this thing a little shorter. I may not need it that long. Let me make it just 10 feet long. And we'll make it the same exact size, so we'll make it 3 by 3 because we want our main duct to be the same size. Again, these are variables. You can set them any way you want. So now let's close this and get this lined up. So we'll go to top view to do that. And I'll bring this side down around here and line it up. Now, nice thing again about CoolSim with this new feature is that we're able to attach these things. So here, I just line it up right on that duct. I right mouse click it, edit, and then all I have to do is something called Smart Length. Hit the Smart Length button. By the way, Smart Length will grow the duct in the positive direction. So positive X is to the right, So if I add smart length, it'll just connect it to that cooling unit right there. Okay, so there's one side. The other side I can do as well. I can copy paste this side if I want. Control C, Control V. Just drop it in over there, go to top, and get it aligned however I want. Now this alignment might be a little more tricky because I can't smart length it because it will increase in the X direction. So I need to just bring these things together so that they're connected. So let me just bring that up like this, and then I right mouse it, open Duct Designer. In this case I need to open the whole Duct Designer here. And so there I am with this particular duct, and I need to bring it up very close to that unit, and they need to touch. There's two ways to do this. One of them is I can just bring it up like this and adjust it. That'll probably work. That'll most likely work. The other thing I can do is to just put a subduct here and connect it by using the automated method. So let me show you how to do that. I'm going to zoom in here. I'm going to put a subduct on this end. So add duct. Now it's too long. That won't connect because it's overlapping. It doesn't know how to connect if they're overlapping. So you need to bring that length back so that it's fairly close, something like that. So there's a bit of a gap between them. And then you hit connect. And now we're connected. Now we have an overhead unit with two ducts coming off either side. I can put subducts anywhere I want by just hitting again, it interprets your cursor position. So I'm pointing right here at this side of the duct. I want to make a duct extend in this direction. So I simply hit add duct and it extends it. If I use smart length, it'll take it all the way to the wall. And then I can apply. And then I flip it over. I don't want to add diffusers. Now this might be a little difficult. See, it doesn't, well, I guess it's going to be okay. Yep, it's going to be okay. I was going to say that sometimes you have to add diffusers using, I can do it either way. I can point at it and right mouse click it and add diffuser. The other way to do it is to use the full Duct Designer. So here I would right mouse and then go for Open Duct Designer. It knows that I was working on that one because that's where my cursor was when I started, to open the Duct Designer. But here I want to add another diffuser. You can do it all from here. I want to add a diffuser on the Y minimum side of this duct. The Y positive would be top. I want the bottom. I want a diffuser. Now it's going to put it right in the middle because it doesn't know where you want it. Put it right in the middle and then you just position it to wherever you want. That's size. Here's center Z, allows you to slide it. Set the percent area open. You're good to go. I can do the same thing over here on this side. Add duct. Right mouse it, pointing at the surface and then just putting it wherever you want is the easiest way to work with the ducting tool. But when you flip it over, sometimes it gets difficult to put these diffusers in. So we give you the opportunity to do that using the full designer. So there's my basic design. Now, one thing to remember here, I'm going to put some racks in the room, and now I have a data center. Okay, that's the necessary component. You need a rack and one crack in order to run. One thing I want to point out here, though, is that what I've built is actually a dead zone in this ceiling area because my air is coming in and out of these ducts, and it's not actually going into the ceiling area. So if we look at the ceiling, we'll see this plenum area, that it's an isolated volume. CFD solvers don't like isolated volumes. They don't necessarily work well that way. Sometimes they'll diverge because they have to calculate a pressure drop across the surface of two independent volumes. To solve that problem here, I'm just going to put a ceiling grill in the dead zone area. So that should be fine. And I can make this as small as I want. So if you want to make this nice and small so that it's not really in the way or that it doesn't raise concerns by someone who's looking at results. So here's my model as I've created it. You can see over here I have my single ceiling tile just placed into the edge. I can double click that, of course, and look, I have it set for 50% open. It doesn't need to be that big. You can have it down to 5% open. It's just we're letting a little bit of pressure and of course the CFD solver to be able to compute pressure across the boundary between the ceiling and that dead zone, or the room in that dead zone. So here's my model that I've created with my crack unit attached in the ceiling. My diffusers set down. I put one small ceiling tile in place just to allow the pressure to balance between the room and the ceiling itself. And I've got it set for 50% open. You can set this for whatever you want as long as there is a connection to allow the pressure to be calculated between surfaces or between independent volumes. Again, what I have here is an independent volume outside this ductwork that is not connected to the room. So I put that in just to make the solver a little happy, be able to calculate that differential. And now I can go ahead and solve. So here's my indicator here. I've got force medium fine. I don't need to check my pre-simulation report. I should be all set. And I go ahead and hit the solve button. The file gets packaged and uploaded to the server, and the job begins. I can track the status of the job by hitting my status button, and it will give me a dialog and allow me to know where my model is in all various stages of completion. You can see here that the job has been uploaded, the input file has been generated, the job has begun, and it's currently in the meshing stage. A small model like this doesn't take very long, so the meshing stage will probably be done the next time that the system checks the server, which it does once per minute. So you see there's a small clock running, and when this winds down it will check again, and it's quite likely will be in equation. And then graphics is very fast, report generation download is very fast. So that's how that works. It's just about to do another check. Chances are it'll be through the mesh stage at this point. Connecting. And yes, it's past mesh. Now it's in the equation solution stage. This stage can take a little longer depending upon the size of the model. So generally the longest stage is equation solution. And then of course graphics is quick, report generation is very fast. You can see here that I just did a status and the job is successfully completed, and now the report is being downloaded. So here's my output report. It downloads right here into the background. It is just as you would expect in terms of output. I have the path lines from the cracks, which are, you can see coming through the ducts and then out my diffusers. You can also see the plots from the racks themselves and where that air is going back up into the system. You can also, we have a plot of the flow rates coming out of the diffusers. This is a nice plot right here. You can see there's a top view. I can go to a Y and take on a perspective. There I have in color the flow rate on each one of those tiles. You can see this one's quite high because of course it's at the end, so it builds up pressure. This one here, red, is kind of low because it's close to that crack, so it's very high velocity. But you can also set the percent area open on these, of course, to balance a system like this, so it gives you the right amount of air out of each one of them. But that's how you do a overhead cooling unit. This can be modeled as if it's outside the building or up in the plenum. Very easy to do and very fast in CoolSim 4. Thank you.